Imagine an element so elusive it's yet to be fully discovered. This is ununenium, or element 119. Ununenium is a bit like a ghost in the world of chemistry. It's a hypothetical alkali metal predicted to be the lightest element in the 8th period of the periodic table. This is like saying it's expected to be a new kid on the block, joining the ranks of well-known elements like hydrogen, lithium, and sodium. But as of now, it's still in the realm of theory, waiting to be confirmed. Why is it so hard to find, you might ask? Well, ununenium doesn't exist naturally. Scientists have been trying to create it in labs since 2018. The main stage for these attempts has been Japan, where dedicated teams have been working tirelessly to bring this elusive element to life, and the race is heating up with upcoming attempts planned in Russia and China. It's a global effort, a testament to the relentless pursuit of knowledge that defines the scientific community. But what makes ununenium so fascinating? It's not just its elusive nature, it's the properties that this element is expected to have. You see, ununenium's properties are predicted to be influenced by something called relativistic effects. This could lead to some unique and interesting behavior. For example, it's expected to show oxidation states of +1, +3, and +5. To put it in simpler terms, ununenium could interact with other elements in ways we've never seen before. This could open up new doors in our understanding of chemistry and the universe itself. Ununenium's properties, influenced by relativistic effects, could lead to unique behavior such as exhibiting oxidation states of +1, +3, and +5. The creation of super-heavy elements like ununenium is a complex process. It involves the fusion of two nuclei. We're delving right into the heart of the matter. The synthesis of super-heavy nuclei, including the hypothetical element ununenium, relies on nuclear reactions. This process can be likened to a grand cosmic dance, where two atomic nuclei come together, merging into one. This fusion is no small feat. The two nuclei are both positively charged and, like charges, repel each other. So, overcoming this repulsion to allow the nuclei to come close enough to fuse is a challenge. But with enough speed and perfectly aligned conditions, they can overcome this barrier and merge. Once the fusion occurs, we don't immediately have our new super-heavy nucleus. This newborn nucleus is typically in an excited state, with an excess of energy. It needs to cool down, and it does this through a process called neutron emission. This is where it emits neutrons, reducing its energy until it reaches a stable state. But how do we know if we've successfully created a new super-heavy element like ununenium? That's where decay and detection processes come into play. Super-heavy nuclei primarily decay through two processes: alpha decay and spontaneous fission. In alpha decay, the nucleus emits an alpha particle, which is essentially a helium nucleus. On the other hand, spontaneous fission involves the nucleus splitting into two smaller nuclei. Detecting these decay products allows scientists to confirm the creation of a new element. The decay patterns are like fingerprints, unique to each element. By studying these patterns, we can confirm if we've indeed synthesized a new super-heavy element. These super-heavy nuclei primarily decay through alpha decay and spontaneous fission. So, the process of creating and detecting super-heavy elements is a fascinating journey, one that takes us to the very limits of our understanding of the atomic world. It's a journey that is still ongoing, with many exciting discoveries yet to come. There's a fascinating concept in the world of super-heavy elements, the island of stability. This intriguing idea revolves around the prediction that there exists a region in the chart of nuclides, where super-heavy elements, like ununenium, could display increased stability compared to their neighbors. The term island is quite apt here, as this zone of stability is surrounded by a sea of less stable elements. Now, what makes this island so special? It's all about the magic number of nucleons, which is predicted to be around 300. Nucleons are the particles found in an atom's nucleus, namely protons and neutrons. The magic number is a specific number of nucleons that create complete shells within the nucleus. This shell completion results in a much more stable nucleus, hence the term magic. In the context of ununenium, this is particularly significant. As the lightest element in the 8th period of the periodic table, ununenium is expected to exhibit certain unique behaviors due to relativistic effects. These include showing oxidation states of +1, +3, and +5. However, these behaviors are just predictions at this point, as ununenium is yet to be synthesized successfully. The island of stability is not just a theoretical curiosity. It has major implications for our understanding of atomic structure and nuclear physics. It could also lead to the discovery of new, super-heavy elements with unexpected properties, which could open up new avenues in science and technology. As we delve deeper into the world of super-heavy elements, the island of stability continues to be a guiding beacon. It stands as a testament to the incredible intricacy and beauty of the atomic world, and the endless possibilities it holds. Experimental evidence has shown the importance of shell effects in determining the stability of super-heavy nuclei. So, why all this fuss about ununenium, a yet undiscovered element, you might be asking? Well, the successful synthesis of ununenium could potentially open a whole new world of scientific advancements and benefits. We're not just talking about another element to add to the periodic table. No, we're talking about an element that could fundamentally transform our understanding of the periodic table and the very nature of elements themselves. Ununenium, if discovered, is expected to be the lightest element in the 8th period of the periodic table. And this alone makes it an object of intense scientific curiosity. Its properties are predicted to be influenced by relativistic effects, which could lead to unique behavior, such as showing oxidation states of +1, +3, and +5. This could potentially challenge our existing knowledge of elemental properties and open up new avenues of research and application. The synthesis of super-heavy nuclei like ununenium involves the fusion of two nuclei through nuclear reactions, followed by decay and detection processes to confirm the creation of a new element. This intricate process is not only a testament to human ingenuity, but also a potential goldmine for scientific discovery. It's also important to note that super-heavy nuclei, including ununenium, are primarily observed to decay through alpha decay and spontaneous fission. This means that the discovery of ununenium could provide us with valuable insights into these decay processes, potentially leading to advancements in nuclear technology. Moreover, the ongoing attempts to synthesize ununenium are a testament to international scientific collaboration, with efforts underway in Japan and future attempts planned in Russia and China. The discovery of ununenium could therefore not only rewrite our understanding of elements but also foster international cooperation in the scientific community. Lastly, the synthesis of ununenium could potentially lead us to the island of stability, a theoretical region of the periodic table where super-heavy elements exhibit increased stability. This could revolutionize our understanding of super-heavy elements and potentially lead to the discovery of even heavier stable elements. The discovery of ununenium could rewrite the way we understand elements and their properties. And that, in essence, is why the scientific community is so excited about the potential discovery of ununenium. It's more than just another element. It's a key new understanding of our universe. Ununenium, a potential game-changer in the world of chemistry, remains a fascinating subject of study. In the grand scheme of scientific exploration, this hypothetical alkali metal, known as element 119, is expected to be the lightest element in the 8th period of the periodic table. The ongoing attempts to synthesize ununenium since 2018 in Japan, with future efforts being planned in Russia and China, are a testament to the relentless pursuit of knowledge and understanding in the scientific community. The predicted properties of ununenium, influenced by relativistic effects, suggest unique behavior like showing oxidation states of +1, +3, and +5. The process of synthesizing super-heavy nuclei, such as ununenium, involves the fusion of two nuclei through nuclear reactions. These processes are followed by subsequent decay and detection processes to confirm the creation of a new element. The theory of an island of stability for nuclei with around 300 nucleons is one that has piqued interest and continues to drive research in this field. We thank the contributors to this Wikipedia article for their comprehensive information on ununenium. The link is listed in the description, and we urge you to click on it to see the full articles and their illustrations. Please click on the link in the description that leads you to our Amazon and other affiliates' website page for making your everyday purchases. Please like, subscribe, share, and click on the notification bell. And thank you very much for those who have already decided to subscribe to our channel. Today, we celebrate a modest yet meaningful milestone. In a span of just 3 months, this channel has grown, reaching a heartening 100 subscribers. We thank you so very much. It's a humble beginning indeed, but every journey starts with a single step. and this is ours. Each and every one of you plays a vital role in this journey, your continuous support being the bedrock of our endeavor. We're eager to continue to improve the quality of our content. To that end, we encourage you to suggest topics you'd like us to explore in the comments. Your support fuels our passion for sharing knowledge. This is a follow-up video about our new moon. Now, you'd think something as common as a moon would have a clear-cut definition, but surprisingly, the International Astronomical Union, or IAU, doesn't have a specific scientific definition for a moon. This of course presents certain challenges when it comes to classifying celestial objects, a dilemma we witnessed firsthand with the controversial demotion of Pluto to a dwarf planet back in 2006. The world of moons is a diverse one, hosting both regular and irregular satellites. Regular moons, like our very own Luna, orbit in the same plane as their parent planet. They're the well-behaved children of the planetary family. Then we have the irregular moons, the rebels if you will, with their eccentric orbits that don't conform to the norm. But the rabbit hole goes even deeper. Have you ever heard of moons? It's not a typo, but a term that's been speculated to describe moons that orbit other moons. It sounds like something out of a science fiction novel, but it's a concept that's been seriously considered by researchers. This informal definition of a moon as an object orbiting a planet or dwarf planet is deemed sufficient by many. But as we continue to explore the cosmos and uncover new celestial bodies, who knows? We may soon have to expand our understanding of what constitutes a moon. As we venture deeper into space, our understanding of moons continues to evolve. It's a thrilling journey of discovery, and there's no telling what exciting revelations await us just around the cosmic corner. Did you know our planet has a second moon? It's not something you see in the night sky, but it's out there, orbiting in sync with our Earth. Meet Copilot, an asteroid that's claimed the title of Earth's second moon. This celestial body was discovered back in 2016, and it measures somewhere between 130 to 330 feet across, roughly the size of the Statue of Liberty. But where did Copilot come from? That's a question that intrigued scientists for years. Through a combination of computer models and numerical simulations, they've managed to trace its origin back to the Giordano Bruno crater on the far side of our familiar moon. Yes, our second moon in a way is a child of our first. Now you might be wondering, how do we know all this? Well, the credit goes to the relentless efforts of scientists who have been tracking and studying Copilot since its discovery, and their work is far from over. In fact, there's a significant mission planned for next year. China's Tianwen-2 mission aims to further study this intriguing asteroid, which will undoubtedly shed more light on Copilot and its unique characteristics. This exploration is not just about understanding Copilot, it's about gaining deeper insights into our universe, the dynamics of celestial bodies, and how they interact with each other. It's about unraveling the mysteries that the cosmos holds and bringing that knowledge home to Earth. Copilot, our second moon, is a fascinating testament to the wonders of our universe. And as we continue to learn more about it, we're reminded of how much there is still to discover in the vast expanse of space. We may have two moons, but we are just one small part of a much larger, ever-evolving cosmic story. What are the implications of Earth having two moons? It's a thought that's bound to stir up some curiosity. Let's delve into the intriguing world of celestial mechanics and uncover the potential effects of two moons on our Earth-like planet. Let's start with the gravitational forces. Now, gravity is not just a force that keeps us grounded, it's a cosmic glue that holds the universe together. Every object exerts a gravitational pull on every other object. So introducing a second moon into Earth's orbit would create a complex dance of gravitational interactions. The pull from two moons could cause Earth's axis to wobble more than it does now, leading to more pronounced changes in our seasons. Next, we come to tidal impacts. The tides on Earth are primarily driven by the gravitational pull of our moon. Now imagine adding another moon into the mix. The tides would become more complex, with potentially higher highs and lower lows. Coastal areas could experience dramatic changes, with some areas becoming submerged while others might emerge. But what about the moons themselves? Could they collide? Well, that would depend on their respective orbits. If the two moons were on a collision course, the resulting impact could send debris hurtling towards Earth, leading to catastrophic events similar to those believed to have caused mass extinctions in the past. On the other hand, if the moons were in stable orbits, they could coexist peacefully. However, their combined gravitational pull might tug on each other, causing their orbits to change over time. This could result in a complex and unpredictable dance of the moons in the night sky. Now, these are just mathematical estimations and theoretical implications. The actual effects would depend on a myriad of factors, including the sizes, distances, and orbital characteristics of the moons. But one thing is for certain: the presence of two moons would indeed reshape our world in unimaginable ways. As we conclude our journey into the realm of moons, it's clear that understanding these celestial bodies broadens our perspective of the cosmos. We've explored what it takes for an object to be considered a moon, met Earth's intriguing second moon, Kama'oalewa, and speculated on the effects of having two moons. Our exploration doesn't have to stop here. For those of you keen to delve deeper, we've used fantastic resources from Forbes, Live Science, and the Astronomy Stack Exchange Network. You'll find these articles linked in the description below. They're packed with more details, and we highly recommend checking them out. Now let's take a moment to appreciate the support that makes these explorations possible. We have promotional links in the description that help sustain this channel. By making everyday purchases through American Northwest Products websites, Amazon, and other affiliates' storefront, you are directly contributing to our journey of knowledge. And lastly, a huge thank you to each one of our 100 subscribers. Your support over the past 3 months has been incredible. We're excited to keep producing content that fuels curiosity and fosters learning. Remember, every click, like, and share contributes to the growth of this channel. Thank you for being part of our journey.
Have you ever wondered if our perception of reality is all there is, or could there be more to it, perhaps even a higher power at play? This is a question that humans have grappled with for centuries, from ancient philosophers to modern scientists. We yearn to understand the fabric of existence, to unravel the enigma of our place within the vast cosmos. Our curiosity propels us beyond the visible, the tangible, into the realms of the unknown. We gaze at the stars, but do we ever consider that the answers might not lie in the infinite expanse above, but rather in the infinitesimal world beneath? A world that defies our conventional understanding of reality. As we delve deeper into this microcosm, we encounter phenomena that seem to suggest a universe far more interconnected than we ever imagined. So what if the answers we seek lie not in the heavens above, but in the minuscule world of quantum physics? Imagine if two dancers, separated by vast distances, could mirror each other's movements instantaneously. This is the essence of quantum entanglement. Quantum entanglement is a phenomenon that seems to defy our everyday understanding of the world. To illustrate the concept, let's imagine a dance. Two dancers twirling and leaping in perfect harmony. Now imagine these dancers are separated not by a few feet, but by vast distances, miles, even light years apart. Yet their dance continues, perfectly synchronized, each responding to the other's movements instantaneously, with no visible means of communication. This is the curious dance of quantum entanglement, a dance of particles. When two particles become entangled, they form a bond, a connection that transcends space and time. The state of one particle is instantly mirrored by the other, regardless of the distance between them. If one particle spins up, the other spins down, and the change is immediate, faster than the speed of light. Now you might be wondering, how is this possible? The answer lies in the weird and wonderful world of quantum physics, a realm where the rules of classical physics are turned on their head. Here, particles can be in two places at once. They can pass through walls, and they can be both a particle and a wave at the same time. In the quantum world, particles are not separate entities but are deeply connected in a holistic web of relationships. This interconnectedness suggests that, at a fundamental level, everything in the universe is linked, part of a unified whole. What's fascinating about quantum entanglement is that it challenges our understanding of the universe and the nature of reality. It brings into question the very concept of separation and individuality, suggesting a much deeper level of connectivity than we ever imagined possible. In the realm of quantum physics, distance seems to lose its meaning. But what does this imply about the fabric of reality? Quantum entanglement challenges our understanding of the universe. hinting at a deeply interconnected reality. Imagine two particles, no matter how far apart they are, behaving as if they are two sides of the same coin. This is quantum entanglement, a phenomenon that shatters our conventional understanding of how the world works. The implications of quantum entanglement are profound. It contradicts our everyday experiences, suggesting that the universe operates on principles that are quite alien to our daily lives. In our world, actions and reactions are local, confined to where they occur. But quantum entanglement tells a different story. It speaks of a world where actions at one place can instantaneously influence happenings at another, and no matter the distance. This seems to defy the very structure of space and time as we understand it. This phenomenon brings up the tantalizing possibility of faster-than-light communication. If two entangled particles can interact instantaneously, couldn't we use this to send messages faster than light? But here's the catch. Relativity, another pillar of modern physics, holds that nothing can travel faster than light. So we are left with a paradox. Two fundamental theories of physics, both validated by countless experiments, appear to contradict each other. So what does this mean for our understanding of reality? Quantum entanglement seems to suggest that the universe is deeply interconnected in ways we don't yet fully understand. It hints at a reality that is non-local, where distance is irrelevant. It raises questions about the fundamental nature of space, time, and reality itself. As we delve deeper into the quantum world, we encounter phenomena that seem to defy logic. Could this be a sign of a higher power? After all, the universe has always been full of surprises, and perhaps in the dance of entangled particles, we are catching a glimpse of a grand cosmic ballet, choreographed by principles far beyond our current understanding. Could the mysteries of quantum entanglement point towards the existence of a higher power? This question has intrigued many, from scientists to spiritual seekers. The peculiarities of quantum mechanics often seem to defy our everyday understanding of reality, making room for interpretations that transcend the purely physical. Quantum entanglement, where particles become mysteriously interconnected, behaving as if they are part of a unified whole, has led some to speculate about the existence of a higher power. This is not to say that quantum mechanics proves the existence of a divine entity. Rather, for those inclined to spiritual thinking, the enigmatic behavior of entangled particles could be seen as a reflection of a deeper, more holistic reality. A reality that is, perhaps, orchestrated by a higher power. This perspective, however, is not universally accepted. Many scientists insist that quantum mechanics, including entanglement, can be fully understood within the framework of natural laws. They argue that quantum phenomena, while counterintuitive, do not necessitate the intervention of a divine entity. Instead, they are simply manifestations of the fundamental workings of the universe, yet to be fully grasped by human intellect. In contrast, others suggest that the interplay of quantum particles might hint at an underlying intelligence, a cosmic consciousness, orchestrating the dance of the universe. This viewpoint often resonates with those who seek a convergence of science and spirituality, seeing in the quantum world an echo of ancient wisdom traditions that speak of unity, interconnectedness, and a divine underpinning to existence. These varied interpretations remind us of the richness and complexity of the quantum world. They invite us to approach the mysteries of the universe with humility, curiosity, and an open mind. It's important to remember, though, these are metaphysical speculations, not scientific conclusions. Whether quantum entanglement is a divine signature or a natural phenomenon, it certainly broadens our understanding of the universe. So let's keep exploring, keep wondering, and who knows? Perhaps in the dance of entangled particles, we'll find clues to the grandest questions of existence. As we stand on the brink of this vast quantum landscape, we realize that our quest for understanding has only just begun. We've delved into the depths of reality, danced with entangled particles, and pondered the profound implications of this quantum ballet. But this is just the tip of the quantum iceberg. Quantum entanglement has shown us that the universe is more interconnected than we ever could have imagined. It's a marvel that challenges our understanding of reality and invites us to consider the existence of a higher power. We've begun to see that our world is not just a collection of separate parts, but a grand, intricate web of relationships. So keep exploring, keep questioning. The universe is a vast, enchanting mystery waiting to be unraveled. In the end, whether you see quantum entanglement as a scientific marvel or a divine mystery, it undeniably opens up a world of possibilities, pushing the boundaries of what we know and what we can imagine.